Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to take a look at some of the larger asteroids that are in the asteroid belt. So we're here looking at the sky during the day for the 1st of May. We'll remove the atmosphere and we can see planets around the sun, particularly Mercury, Mars and Saturn here on the western side of the sun. Saturn is coming back into view in the morning for us here in Ireland as we come through May. But if we turn back around to the east here for sunrise, you'll see that it's not quite visible for us just yet. If we bring back the atmosphere, Saturn and Mars are out of view. But due to the conjunctions that have been happening, that happened last month with these planets next to the Sun, while we were taking a look at them, of course, we saw a couple of comets. Neptune is out there as well. But here is Vesta and Pallas, two of the larger asteroids in the asteroid belt. Not the largest, but definitely quite close. In fact, one could argue that Vesta is the largest asteroid in the asteroid belt if Ceres is classified as a dwarf planet, but Ceres is normally double classified as both a dwarf planet and an asteroid. So we can see those minor planets, those minor bodies, those asteroids, they are further from the sun at sunrise than Saturn, then Neptune, which means they're going to be a little bit easier to see. Of course, they're going to get easier and easier as we push further and further into the year. It looks like they may have just gone below the horizon there. Oh, well, there's Pallas still above the horizon, Vesta just below. So we'll take a quick closer look at Pallas. It is the one that is up currently, technically above the horizon, and we will see a sort of round shape. Pallas isn't considered a dwarf planet, and one of the reasons it's not considered a dwarf planet is because it isn't really under hydrostatic equilibrium. It hasn't really made itself round. It is lumpier and bumpier than this image makes it seem. We can see that it's quite faint here at just 10th magnitude, and that's without the atmosphere. With the atmosphere turned on, being so low in the sky, it's reduced to just 12th magnitude, which makes Pallas a tough target. And we're seeing it here definitely in the glow of sunrise. I don't think it will stay not very far above the horizon. It won't be up above the horizon when the sky is truly dark just yet, not for another little while. Pallas is an asteroid and it is orbiting the sun. Its period here is showing 4 years and it is about 3 times further from the sun than we are. So it is orbiting the sun pretty slowly, and that means that its position in the sky is mostly going to change because of our orbit around the sun, very similar to Saturn and Jupiter and those more distant planets. Vesta should be just a little below Neptune, so we'll get that back above the horizon. As you can see, Vesta is further from the sun than Pallas, but Pallas is higher above the ecliptic. It looks like Vesta is pretty close to the ecliptic here, lining up with Saturn and those other planets. That's putting it even lower to the horizon. The asteroids in the asteroid belt, many of them vary pretty far from the ecliptic. Compared to the planets, some of the asteroids can be much more highly inclined. So here we are, Vesta. We can see 4 Vesta here because it was the 4th asteroid to be discovered, and we can see that it's there at magnitude 7.8. Of course, it's so low in the sky and so close to sunrise, it's getting reduced to 10th magnitude. But 7.8, that is significantly brighter than Pallas, and it is just about within the realm of what you can see with a telescope and binoculars. Of course, Vesta is quite small, so it will only appear as a small dot through telescopes and binoculars. We can see that it looks pretty round here as well, but it's also only considered an asteroid and not a dwarf planet. We've got 2 and 4, Pallas and Vesta. Those are Vesta, at least, is one of the largest. Pallas is quite large as well, but the largest asteroid is the dwarf planet Ceres. Ceres, I don't believe, is in a great position for us to see at the moment. It looks like it's under the horizon there and up at sunset, but not very high, I would assume. There we go. So it's there just setting with the sun, a little bit further from the horizon than the sun, but as you can see, not far enough to be above the horizon in darkness, at least not with the view that we have here. We will remove the trees, the buildings, we will go to a flatter horizon, because if you are at the coast, you will be able to watch things get closer to the horizon than we're able to see them here with those trees in the way. So of course there's the sun not even set yet. There's the setting sun. Ceres still above the horizon, but not really in a position where we're going to be able to see it. We can see it listed here as a dwarf planet. It is still considered the first asteroid, and it's there at magnitude 8.84, which is faint for Ceres. Ceres here is practically on the far side of the sun from us. It's about as far from us as it can get. You can see that it's just under 3 times as far from the sun as we are, but it's an extra AU away from us here, being on the far side of the sun. But we'll get rid of the atmosphere. This, I believe, is its orbit. So its orbit is coming up, and we'll take a closer look at Ceres, which is certainly round. Here we go. Looks very similar to a small planet or the moons of many planets. Ceres is under hydrostatic equilibrium, big enough and round enough to be a dwarf planet. It isn't in control of its orbit. Of course, Ceres shares its space with various other asteroids, but Ceres is the bulk of the asteroid belt. Ceres is so much larger than the other asteroids, even the other large asteroids like Vesta and Pallas. Ceres is so much larger that it makes up the bulk of the asteroid belt. We can see some other asteroids here as well. There's a 6 Hebe, not a particularly big one. We can see its magnitude there is just 10th magnitude. It's a little bit smaller than Pallas and Vesta. It's not the 6th largest asteroid, but it was the 6th to be discovered. There are lists in Stellarium. We've used them a few times before to find different things in the sky. As you can see here, they're not ordered. They are ordered by the first number, but of course this means that 3 is followed by 311,999, followed by 3,200. So they're not in order of discovery or anything like that. Juno is the 3rd asteroid. We've already looked now at 1, 2, and 4. So this is 3. And we can see Juno here, also about 10th magnitude. This is without any atmosphere in the way, making things worse. We can see it also looks like this little ball, but these little balls aren't quite the same as the spherical shape that forms when a body is under hydrostatic equilibrium. There's a good chance that the material inside these asteroids, it hasn't been squeezed into one solid mass. That makes these asteroids a little bit more like balls of gravel rather than solid balls of rock, but that is part of what makes them not under hydrostatic equilibrium. The fact that they are spherical or close to spherical or appear spherical doesn't necessarily mean that they are under hydrostatic equilibrium. Normally people say big enough and round enough, or big enough and heavy enough to become round, to become a ball under its own gravity. But even a looser association of material will come together in a sort of a spherical way, but they can be lumpier and bumpier. Asteroids aren't very well understood because it's of course very difficult for us to get to them. There have been probes that have visited asteroids and flown past asteroids, but there is still a lot that we don't know about them, even quite big and famous ones like Juno, like Vesta, like Ceres and Pallas. So they are a few of the larger asteroids in our solar system, including the asteroid that's big enough to be considered a dwarf planet, Ceres. They happen to be, or at least Pallas and Vesta happen to be, quite close to the sunrise at the moment, quite near to where those planets, Saturn, Mercury, Mars and Neptune, are, just on the west side of the sun. So they'll be coming back into view over the near future, the same way that Saturn's coming into view here as we get into next month. So I hope you enjoyed this look at those objects. They're not the most famous objects, they're not quite as famous as the planets, but they are out there in our solar system as well. I hope that you enjoyed this video. If you did, please do like it. If you like this kind of content, then please subscribe to my YouTube channel. And if you'd like to read this information written down, you can do so on my website, queevinscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.